All right, this is Mr. Gillum, and today we're going to talk about exponents, and we are moving away from the number system and more into expressions and equations. Today we're going to be identifying exponents and bases, as well as writing expressions in exponential notation. To begin, I guess, let's talk about just what an exponent is and where it's at. An exponent is the small number up here in the top right-hand corner, 2 in this case. That number is called the exponent. There's another term called the base. That's the bigger number. Okay, so the base is the bigger number. So 8 to the second power is how we would read that. And I want you to very carefully, I want you to look at the difference between the size of the 2 and the size of the 8. The 2 is specifically smaller, and it's in the top right-hand corner. The 8 is specifically bigger, visibly bigger, and we call that the base number. Now, the 2 is not in the top left, or the bottom right corner. It's not right next to it like an 82. And it doesn't mean multiply 8 times 2, which is 16. Okay, the exponent tells you how many times the base number is being multiplied, or how many of them is there. So 8 squared would be represented by 8 times 8. Okay, there are 2 8s. Okay, and so the whole thing altogether, 3 squared or 6 to the third or whatever it is, 9 to the fifth, the whole thing altogether is called a power. Okay, it's a power expression. And so those are all types of powers. Okay, the whole expression altogether. Okay, in the power there are 2 parts, the base and the exponent. All right, so let's take a look here now that we've identified exponents and bases at another problem. Okay, few things to remember on exponents. It says an exponent is never multiplied by the base. So, for instance, if I had 3 to the second power, it does not equal 6. It would equal 3 times 3, which is 9. Okay, the common mistake that I see is that people just think it's a multiplication problem. No, if we wanted to multiply 3 times 2, we would just write it as 3 times 2. Okay, there's a reason we're writing it differently with 3 to the second power. All right, it is not the same as 3 times 2. So the same thing goes for like 6 to the third. We would write that, or we would think of that as 6 times 6 times 6. We would not just take 6 times 3, which would be 18. 6 to the third does not equal 18. Okay, it equals 36 times 6, which is 216. And you can see just as well as me that 18 and 216 are very far apart, and they're completely different numbers. Okay, a power is just a way to write a big long multiplication problem in a smaller, more compact way, because as the years go on, the equations get bigger for you guys, and the expressions get bigger, or the numbers get bigger. And so instead of writing 2 times 2 times 2 times 2 times 2, I mean, it just gets redundant. It's just kind of silly for me to stay here. I'm going to use 3 lines of my paper just writing the problem down. So a better way to write that would be 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, ninth power. Okay, it's much easier to write down. It's like a shorthand. Okay, we write like English words. The word with, maybe you've seen this before. The word with we would write as a W/. Okay, or for the word example, your teacher probably doesn't write the word example out every single time. They probably just use EX. Okay, it's like shorthand. Well, this is kind of the same way an exponent works, or a base works, I should say. Instead of writing out the entire thing, it's just kind of silly. We're just going to write it out as 2 to the 9th power if there's 9 2's. It's a shorthand way to write something that you're trying to express without having to write everything out. Okay, so looking at this next part here, we call this exponential notation. All right, exponential notation. And what it means is we're just going to write these long expressions in a more shorter, compact way. So the exponential notation of 3 times 3 would be 3 to the second power, or we have 3 2 times. 3 to the third. If we had a multiplication problem with 4 3's being multiplied, it'd be 3 to the fourth. 3 to the fifth, obviously, 3 to the sixth. I think you see the pattern here, 3 to the seventh. Now, obviously, 3 times 3 is not the same as 6. It does not equal 9. or 12, or 15, or 18, or 21. You are not multiplying, so please do not multiply the exponent times the base. Okay, this is a shorthand way of writing a huge problem out. So it's just really, it's a convenience to you to be able to use this exponent instead of writing down a problem with a whole bunch of numbers in it. Okay, it's a shortcut. I will also say, and I would like you to write this on your paper as well, that multiplication is commutative, meaning that 3 times 2 and 2 times 3 are the same thing. So when you get to a more complicated problem, like 3 times 3 times 3 times 2 times 2 times 2 times 3 times 2, instead of writing it all out like that, it'd be much more efficient for us to use exponential notation. So I'm just going to count up the number of 3's that I have here. 1, 2, 3, 4, 3 to the 4th, times however many 2's I have. 2 to the 4th. So this would be an example of writing this long expression that's just a big long multiplication problem out as exponential notation. Okay? So exponential notation is just a shorthand way to write out a long multiplication problem. Okay? The 4 represents having 4 3's being multiplied together, and the 4 here represents there's 4 2's being multiplied together. All right, those are the exponents. 3 and 2 would be the bases, and together we would call 3 to the 4th a power. We would call it a power. Okay, a few more things to remember. You need to be very careful when you write your exponents, because 3 to the 3rd is different than 33, or 3 with a subscript of 3. They all mean different things. Okay, so this needs to be clearly above and to the top right corner and smaller, significantly smaller. So please be very precise when you write, and don't be sloppy, because it makes a big difference where that 3 is at. We need to be precise with our writing. These numbers that are in the bottom right hand corner, you'll see them more as you get into the higher grades, but they're called subscripts and keeps track of which 3 we're talking about. We're going to learn about that later, so make sure your exponent's not down there below. Make sure it's up here at the top. This just looks like 33. Obviously is not the same thing as 3 to the 3rd power. Let's take a look here and switch some stuff around. It says write this number as a multiplication problem. Okay, looks like we have 2 to the 2nd power. 2 to the 2nd power. So if I'm writing it as a multiplication problem, it would just be 2 times 2. 5 to the 2nd power. That's just saying I have 5 multiplied by itself twice. 7 to the 2nd would be 7 times 7. 9 to the 4th would be 9 times 9 times 9 times 9. And 3 to the 4th, same idea, 3 times 3 times 3 times 3. Okay, the exponent tells you how many times you're multiplying the base by itself. And then vice versa. 6 times 6 would be the same as 6 to the 2nd power. Okay, 9 times 9 times 9 would be like 9 to the 3rd power. The number being multiplied changes into the base. The exponent is the number of times you have the base. 1, 2, 3 times. 8 times 8 times 8, well, the base would be 8, and I have that number 3 times. 4 8s then would be 8 to the 4th, or 4 7s would be 7 to the 4th. Okay, so the number you're being multiplied by multiple times is the base. The number of times you're multiplying it by itself is the exponent. And then there's 2 abbreviations that you need to be familiar with, because I have used these so much that I say them and I forget that maybe you might not know what they mean. If you see a power with an exponent of 2, instead of saying 3 to the 2nd power or 5 to the 2nd power or 8 to the 2nd power, there's an abbreviation for that as well. So you'll learn that powers are just abbreviations. There's abbreviations everywhere. And so when I say the word squared, when I say squared, you need to automatically think in your head to the 2nd power. When I say cubed, you need to automatically think in your head to the 3rd power. So instead of saying 3 to the 2nd power, I would just say this would be, I would say this out loud as 3 squared. okay, or 5 squared or 8 squared. And instead of saying 4 to the third power, 9 to the third power, 6 to the third power, okay, these squares and cubes, they're used very often in math. So instead of saying to the third power, to the third power, to the third power over and over and over, I would just say 4 cubed. And then you would know that I'm talking about the third power, okay? So if I say squared, it's to the second power. If I say cubed, it's to the third power. Okay, so let's take a look here at this last slide. And when it says solve the problems, I think it really means simplify. But on your paper, it will say solve. What I want you to do is actually find the number value of each of these expressions here. And so we start with 7 to the third. And 7 to the third, if you think in your head, 21, you would be incorrect. It does not equal 21. Scribble that out. Make sure you don't write 21. We're thinking whatever 7 times 7 times 7 is. Well, I know that 7 times 7 is 49. And 49 times 7, if I'm not sure about that, I can always try to figure it out. Oopsies. Don't figure it out like that and make a mistake on your arithmetic. 49 times 7 would be 63. There we go, 343. That looks more like it. So 7 times 7 times 7 would be 343. Again, 2 to the second power would be the same as 2 times 2, which we all know is 4. That was an easy one. But 5 to the third, we might try to write down 15 because we're in a hurry and we're not really in the mood to do math, and so we just want to get our assignment done. But I'm going to tell you, I'm going to hand your paper back, and I don't like you to do it again if you just write down 15 on your paper. It should be, you should be thinking whatever 5 times 5 is times 5 is. 3 5s. So we're thinking 25 times 5, which is 125. Okay, so 125 will be 5 to the third is representing 125. 6 to the second, please do not write 12. This does not equal 12. Please do not do that. That is bad, 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 bad. It is saying 6 times 6, which we know is 36 instead. All right. And then when it asks us 4 to the third power, we're not thinking 12. It does not equal 12. Children, please do not put 12. Bad, bad. Okay, it's 4 times 4 times 4. Well, I know 4 times 4 is 16, and 16 times 4 equals 64. Okay, now we're going into that slang that I was talking about. 8 cubed. This is what you're thinking. 8 cubed. What is 8 cubed? Well, that's 8 times 8 times 8, or 64 times 8, 512. Okay, or 7 squared. It's not 14, it's 7 times 7, which is 49. Or 8 squared. When I say squared, I mean to the second power. 8 times 8 would equal 64. 2 cubed, 2 to the third power does not equal 6. People, do not put 6. Bad, 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 bad. It would equal 2 times 2 times 2, which is 4 times 2, or 8. And 5 to the power of 2, we would say that's 5 to the second, or 25. Not 10, people, not 10. Bad. Okay, so that's how an exponent works. Hopefully you got that, and we're going to practice some of this in class today.